last class we started talking about the angle relationships when a transversal is intersecting two or more lines. We talked about those angle relationships and how they work when I have the two lines, and today we're going to actually talk about what happens when those two lines that are intersected by the transversal are parallel. When they're parallel, there are distinct characteristics between each of those angle relationships. So I need to make sure that we are all on the same page. So I need to make sure everybody has this piece of paper in front of them, as well as two highlighters. So if you can make sure that this is all on your desk, if you need to pause this video to make sure you're all caught up. But once you're caught up, when you're ready to go, I need you to highlight your title for me, please. And I also need you to highlight the borders of these boxes down below, because the borders of these boxes are very important because they're going to help us understand those properties and those postulates and theorems about your angle relationships when your lines are parallel. So remember in the first part of this unit, we discussed the difference between postulates and theorems. Postulates are assumed truths, and theorems are things that we've proven we have to prove based on using postulates. So the first one we use is we're going to talk about the corresponding angle theorem postulate. So if you notice this picture, notice I have two lines. I have line L and I have line M, and they're parallel. And how I know those lines are parallel is because it has those arrows here and here. So remember, those arrows just mean parallel. Those arrows I can put anywhere. I can put them on the ends, I can put them in the middle, wherever you want to put them. Remember that it's telling you that those lines are parallel. So my stylus isn't great with this iPad that I'm using tonight, so I'm going to type up the postulate for you. So the first postulate, corresponding angles postulate, it says if two angles are corresponding, then and the lines are parallel, then the angles are congruent. If two angles are corresponding and the lines are parallel, then the two angles are congruent. So remember, we talked about corresponding angles last class, and corresponding angles are angles that are in the exact same position. So angle 1 and angle 2 are both in the top right corner of line L and line M, which makes them corresponding. So now, when the lines are parallel, the two corresponding angles are congruent. So that's an important piece. You might even want to highlight the word congruent. So when they're corresponding, they're congruent. All right, so let's now talk about alternate interior and alternate exterior. Before I even talk about it there, if I look at the alternate interior angles, remember alternate interior angles are angles that are on the inside and then they're on alternate sides. So what would be an example of alternate interior angles? Angle 3 and angle 1. So, okay, alternate interior angles, not that one, let's see here. It says if two lines are parallel, then the alternate interior angles are congruent. This also works for alternate exterior. So if two lines are parallel, then the alternate exterior angles are congruent. So if two lines are parallel, then the alternate interior angles are congruent and the alternate exterior angles are congruent. So alternate interior is congruent, alternate exterior is congruent. So when it's corresponding angles, they're congruent. When it's alternate interior, alternate exterior angles, it's congruent. Another word for congruent? Equal. Okay, so now let's talk about same side interior and exterior angles. So if we talk about same side interior angles, if we go back to this picture, same side interior angles, they're interior angles that are on the same side of the transversal. So which angles are on the same side of the transversal? Angle 1 and angle 2. So if I take a look at angle 1 and angle 2, so obviously if we just go back here for a second, look at alternate interior angles, 3 and 1. Look at angle 3. Angle 3 is what type of angle? Well, it's an acute angle, right? What about angle 1? Angle 1 is also acute angle. So they're acute. So obviously they look like they're congruent. Now, is that a good way to base it off of? Well, no. But just look, they're both acute, so your brain can remember they're congruent. Let's look at the same side interior angles, 2 and 1. Look at angle 2. What type of angle is angle 2? Well, angle 2 is an obtuse angle. Well, how about angle 1? Angle 1 is an acute angle. So there's no way an obtuse angle and an acute angle are going to be congruent. So same side interior angles are actually different. Same side interior angles actually tell us if two lines are parallel, then same side interior and exterior, so we don't have to write it twice, add up to 180 degrees, which essentially means they are what? Supplementary. If two lines are parallel, then same side interior and exterior angles add up to equal 180 degrees. I don't know where I got 120. 180 degrees, which means they're supplementary. So some people are going to ask, well, okay, great. Well, because they're supplementary, does that mean same side interior angles make a linear pair? Well, let's look. If I draw an arc through angle 1, let me not use yellow though. Let's use red. Draw an arc through angle 1 and I draw an arc through angle 2. Does that make a linear pair? No, it's not even a semicircle. So I know that there's the case they're supplementary, not linear pair. So let's go ahead and look at some of these examples. I'm just going to scroll this up. Okay. So it says write all the angles of the given write all the given angles from the given angle. So I've given you one angle, and I'm telling you that these lines are parallel. This is technically bad notation because you can't assume anything is parallel. So if I go ahead and put my arrows in my picture, I can. But okay, great. Well, I want to actually figure out the problems. So with my postulates and my theorems, I have to be able to answer these problems. So if this angle is 75 degrees, what other angle can I say is also 75 degrees? Well, I can say this angle right here is 75 degrees, but how come? Because it's a vertical angle. So I'm going to say, okay, fine, that's 75 degrees. And this stylus hates me, so I'm not going to put the degree sign because it's going to be a nightmare, and you'll be laughing at me virtually. So instead, I'm just not going to do it, and I'm telling you, yes, if I left my degree sign off, I would lose points. But okay, this angle is 75 degrees, and that angle is 75 degrees because these are vertical angles. All right, awesome. What about this angle right here? Why is this angle am I allowed to say this angle is 75 degrees? Well, I can say this angle is 75 degrees for two reasons. Because this location is corresponding to this location, and the postulate up here told me corresponding angles are congruent. So if that's 75 degrees, down here has to be 75 degrees. So I know that's going to be 75 degrees. But I also can say this is 75 degrees because how is this angle here related to this angle there? Well, this angle and that angle, they're alternate interior angles. What do I know about alternate interior angles? They're congruent. So I know it's 75 degrees. All right? So now, what about this angle right here? What about this angle right here? Well, I can also say that's 75 degrees because it's a vertical angle with the one I just wrote. But if we think about it for another reason, this angle is 75 degrees because this angle and this angle are alternate exterior angles. Alternate exterior angles are congruent. And I also know this is 75 degrees because if I look at this angle and this angle, these two angles, they're corresponding. So corresponding angles are also congruent. So the whole bunch of different ways of how you can find those angles. And kind of notice it kind of goes in a zigzag pattern. So all right, I got 1, 2, 3, 4 angles left to find. I found 4. So how do I find this angle right here? Anybody have any idea on what I would do? Well, this angle makes a linear pair with that angle. So if I drew my arcs, notice I get a semicircle. So if that angle is 75 degrees, what does this angle have to be in order for it to make a linear pair? Well, it has to be 105 degrees. All right, and now I just can go through the exact same process. You can say this angle right here is 105 degrees because it's a vertical angle to this guy up here. You can also say this angle is 105 degrees because it makes a linear pair with that one. You can also say this angle is a linear pair, is 105, because this angle and that angle down here are same side interior angles. Same side interior angles add up to equal 180. So that's 105. And I'm just going to keep going in my pattern. This is 105 because of alternate interior angles being congruent, and this is 105. Okay? So now I want to do the exact same thing on the next question. So why don't we pause this video and you try that problem. Try this problem, take maybe 2 minutes, try it on your own, and then unpause it and we'll go over it. So I can follow along and say, okay, 143, I also know this is 143 because I love vertical angles, and vertical angles are easy to find. I can also say this angle is 143 degrees because it's the alternate interior angle to the one that I'm given. And I can also say this angle is 143 degrees because it's vertical to the one that I just wrote, or it's corresponding to the one that was typed up on my paper, or because it's alternate exterior angle from this angle and that angle. So now, if I want to find the next angle, if I want to find this angle right here, I have to do a linear pair with the one that I'm given. So those two angles make a linear pair. So these two make a linear pair. So 180 subtracted from 143 is 37. So if that's 37, down here is 37. And this is 37. And this is 37. And how I know? For a whole bunch of different reasons. Let's go through them. This angle and this angle are supplementary because they're same side interior angles. So I know they have to add up to 180, which they do. This angle and this angle make a linear pair, so I know that they have to be 180. This angle and this angle also same side exterior, which also have to be supplementary. And this angle are corresponding, so I also know they're congruent. So there's a whole bunch of different ways you can get your answers. I didn't just list them all. Those are just some of them. So just keep that in mind as we're progressing. So when you're good, I want you to go ahead and flip your paper for me, please. Excellent. Go ahead and pause this video. And again, before you pause this video, we are assuming that these lines are parallel. So you might want to draw the arrows because it is improper notation. However, tonight on your homework, if you don't have the arrows, we're assuming that they're parallel. If I look over on this tic-tac-toe board, I'm going to assume the two lines that look parallel are parallel. So I'm going to assume that one is parallel to that line. So go ahead and pause this video, do these two problems, and then give yourself about 2.5, 3 minutes, and then unpause this video, and we'll go over it. So hopefully everybody's okay now with when I have one transversal with parallel lines. I can just kind of go up the zigzag pattern. That's 94. Sorry, the stylus is awful. I lost my good one. This is 94, and this is 94. So to find my other angles, I just have to take 180 minus 94, and I get 86. So that's 86, that's 86, that's 86, and that's 86. All right, so if we look at this next one, the tic-tac-toe boards, remember I told you are the hardest problems. I would highlight your parallel lines. So your brain knows those are the lines that are parallel. So your lines tell you, so this nice zigzag pattern that we go in, notice it goes in the zigzag pattern of the parallel lines. So I can only go in the zigzag pattern through my parallel lines. So just kind of keep that in mind. I can't go this way because these lines are not parallel. This line and this line are not parallel. So you just have to go backwards. So you can only go zigzag in one direction. So I'm going to do this transversal first. Probably should have highlighted that instead of wrote it in green. Let's do that transversal first. So, okay. If that's 100, this is 100 because of vertical angles, which makes this 100 because of alternate interior angles, which makes this 100 because of corresponding angles or alternate exterior angles or vertical angles or whatever have you. Hopefully you can read my horrible handwriting here. To find the other one, do a linear pair. 80 because 100 subtracted from 180 is 80. So here's 80, here's 80, here's 80. To do the next one, I just do the exact same thing. This is going to be 98. This is going to be 98. This is going to be 98. To get the other angle, I subtract 180 from it. That's going to be 82. 82. 82. 82. Hopefully you can read that okay. Again, I couldn't go in this direction. I couldn't say 80, 80. Notice 80, these alternate interior angles are not congruent because this line and this line are not parallel. So it's okay because they're not always going to be a perfect parallel tic-tac-toe board. So just kind of keep that in mind. So let's get to the fun part. Here's the fun part. Solving variables. Woo! We love this part. So find the value of x and then find all the missing angles. So the first thing you have to do is you first have to assume that your lines are parallel. If you don't assume your lines are parallel, these problems are impossible to solve. So keep that in mind. So the first thing that you have to do is you have to ask yourself, okay, well, look at the angles that I'm given. Now I need to determine the relationship between those angles to be able to set up an equation. Just like we did when we saw that we had vertical angles, we knew we set them equal to each other because vertical angles are congruent. And the same way when we had linear pairs, we knew to add them up to equal 180 degrees because that was what linear pairs meant. So if I look at this first example, I have this angle and I have this angle. I need to know the relationship between those two blue angles. What's the relationship? Well, they're alternate interior angles. So I'm just going to write AIA up here. So my brain knows and I get used to it. All right, cool. So what do I know about alternate interior angles? When my lines are parallel, alternate interior angles are, well, they're congruent. So congruent means that they're equal. So all I'm going to do is set them equal to each other. So I'm going to say 3x plus 10 equals 5x minus 10. You now all get to experience what it looks like to grade handwriting. That's awful. Sorry that my stylus is so bad, but I have a feeling you'll be okay. So now I set them equal to each other because that's what the formula told, the theorem told me on the other side. So now all I do is solve. So I'm going to subtract 3x to the other side. I'm going to get 2x and I'm going to add 10 to the other side. I'm going to get 20. I'm going to divide by 2. X is 10. Okay, so now all I got to do is plug them back in. So I'm just going to plug it back into this equation. So 3 times 10 plus 10. So 3 times 10 is 30. 30 plus 10 is 40. So this is 40. I would have to put a degree sign, but if I try to put, oh, well, there you go. There's my microscopic degree sign. If I plug it into this bottom equation or expression, 5 times 10 is 50. 50 minus 10 is 40. So now just fill out all the other missing angles, follow the zigzag pattern. So that's 40. If I can write 40, this down here is also 40. To find the other angle, do a linear pair, subtract 40 from 180. I get 140 and fill out the rest. The only way, ladies and gentlemen, you're able to solve these problems like this is when your lines are parallel. I'm telling you the lines are parallel. In the future, on tests that are months down the road, you can't do any of this if your lines are not parallel. So just keep that in mind. Let's look at this next example. First thing I got to do is determine the relationship. What's the relationship between this angle and this angle? Well, they're vertical angles, so I'm going to put a V here. What do you know about vertical angles? Well, they're congruent. So, 3x, stylus does not like x, equals 75. So x equals 25. So 75, 75, 75. Now find the other ones. How do I find the other ones? Linear pair. So it's going to be 105. And then just follow the zigzag to the other way. 105. 105. 105. Awesome. Let's look at the next one. First thing you do is determine the angle relationship. If I put dots on my angles, what's the angle relationship? Well, they're alternate exterior angles. So alternate exterior angles. So what do I know about alternate exterior angles? Well, they're congruent. So what's my equation going to look like? X plus 10 equals 4x minus 20. So now I'm going to solve. I'm going to subtract x and get 3x. I'm going to add 20 to 10 and get 30. So x equals 10. So now I'm going to plug 10 in. 10 plus 10 is 20. So down here is 20. So my expectation is that you fill in the rest of this picture. Fill in all the other angles. So I now want you to pause this video and I want you to attempt the last problem. Attempt the last problem on your own and then we will go over it. So if I put a dot on my two angles that I'm given, what is the relationship between those angles? Well, they're corresponding. What do I know about corresponding angles? They're congruent. So 6x equals 5x plus 15. So subtract 5x, I get x equals 15. So I have full expectation that you could plug 15 into your angles for x, and then you could figure out the rest of these problems. So somewhere on your paper, I don't care where, I need to fit one more example. So you can squeeze it anywhere you'd like. You're more than welcome to get out a separate piece of paper and draw this. So I'm going to draw it. And I'm going to type the angles to make it easier. So just bear with me while I type it, and then I'll read it. Just so you don't have to read my awful chicken scratch. So okay, I have two parallel lines, and I'm going to even draw my angles and my arrows in here so you know that they're parallel. And I'm giving you those two angles. One is 20x plus 5, and the other one is 24x minus 1. I want you to pause this video. I want you to attempt this problem on your own, and then unpause this video, and we'll go over it. So if I mark these two angles, what's the relationship of those two angles? They are same side interior. Same side interior. What do you know about same side interior angles? Well, they're supplementary. They add up to equal 180 degrees. So if I wanted to solve this, I would say 20x plus 5 plus 24x minus 1 equals 180. So now I'm going to add all this stuff up. I have 44x plus 4 equals 180. So now I'm going to subtract 4. So I have 44x equals 176. So now I have 176 divided by 44. X is 4. So yeah, I could then go in and plug it in and find all of my angles if I wanted to. So I just wanted to make sure that you saw one with same side interior angles. So now you're going to work on some practice. Make sure if you have questions, you are asking them. And I will see you next class.